So hello students, welcome to all of you in this video lectures. Here I am going to start the new chapter, which is complex number and quadratic equation. So chapter number 5. The students, let us discuss what is the definition of a complex number. The students, before complex number, all of you should know what is an imaginary number. Okay, so imaginary number can be find out from the equation of this type, x square plus 1 equal to 0. So it's a quadratic equation, and what is the solution of this equation? You can see that x square plus 1, x square equal to minus 1 and x equal to root over minus 1. So this under root negative number cannot be defined. So we cannot find a definite value for a square root of a negative number. So this value under root minus 1, this value is taken as an imaginary number, and with the help of this imaginary number we can find the value of x, which is an imaginary root, which is called imaginary root, and because it gives an imaginary value which is I. So students, what is the value of I? Under root minus 1. So this is called imaginary number, and when you square it, the value of I square will get minus 1. Right? Now a number which contain this imaginary number is called a complex number. For example, a number of the form a plus ib. See, in this number I is there, so I is imaginary number. So in the form of a plus ib, if we write a number like this, where a and b are real numbers but I is an imaginary number, is defined to be a complex number. This type of number is called a complex number, where a is a real number, b is a real number, but I is an imaginary number, and together the number formed a plus ib. For example, 2 plus i3. Okay, so this is a complex number because here 2 and 3 are real numbers and I is a imaginary number. The students, you can see that for the complex number z equal to a plus ib, so this is the standard form of complex number writing z equal to a plus ib, where it can be divided into two parts. This a is called the real part of z, and plus imaginary part, this b is called the imaginary part. Why this b is called imaginary part? Because it is multiplied with an imaginary number. So real z, which is called real z, real part of z is a here, and b is called the imaginary part. So I am z, in short, imaginary z, I am z, which is b. So in any complex number we can find out the real part and imaginary part. For example, in this complex number, if I ask you what is the real part of this complex number, so your answer should be 2. What is the imaginary part? 3. So students, next two complex numbers z1 and z2 are equal. When these two complex numbers are equal? When their real part and imaginary part are equal. So real part a and c must be equal and imaginary part b and d must be equal. Then we can say that the two complex numbers z1 and z2 are equal. So student, there are some algebra of complex numbers, how we can add, subtract, and let z1 equal to a plus ib and z2 equal to c plus id be two complex numbers. Then z1 plus z2, these two complex number can be added or can be subtracted. Like this, 2 plus i3 plus minus 6 plus i5. Students, this 2 is called the real part and this 3 is called imaginary part. So when we add, we have to add the like terms, real part with real part and imaginary part with imaginary part. So you can say that 2 minus 6 plus I, 3i minus 3i plus 5i. You can take I common. 3 plus 5, which is minus 4 plus I8, or you can say 8I. So student, these are some laws of addition of complex numbers, two complex numbers. It can follow the closure law, commutative law, associative law, existence of identity, and the inverse, additive inverse. So students, next difference of two complex number is same as the addition of two complex numbers. We can subtract two complex number like this. 6 plus 3i, it is a one complex number, minus 2 minus I, it is another complex number. So when we subtract, we have to subtract the like terms, like real part with real part. 6 minus 2 and 3i minus plus I, 3i plus I. So it will be 6 minus 2, 4, and 3i plus I, it will be 4i. The 4 plus 4i. Similarly, this one, 2 minus I minus 6 plus 3i. So 2 minus 6 is minus 4, and minus I minus 3i will be minus 4i. This is the value of this subtraction. Next, multiplication of two complex number. How two complex number can be multiplied? In this case, students, you can multiply, let us say two complex number z1 equal to a plus ib and z2 equal to c plus id. So when you multiply these two complex numbers, when we multiply a with c plus id, we will get ac plus aid. And when you multiply ib with c plus id, so first term will be ibc plus I square bd, which is minus bd. So after taking the like terms common, so it will be ac minus bd, ac minus, because I square is minus 1, so ac minus bd plus I common, ad plus bc. For example, 3 plus I5 into 2 plus I6. First you have to multiply 3 into 2, 3 into 2, 3 into 2 minus 5 into 6 plus I common, 3 into 6, 18, 5 into 2, 10. So it will be 6 minus 30 minus 24 plus I 28. So students, there is division of complex number also. We can divide the complex number like this. When you divide the complex number, we have to rationalize the denominator. Suppose here 5 plus root 2i divided by 1 minus root 2i. So how we can divide it? First we have to rationalize the denominator so that we can eliminate the imaginary part. How we can eliminate the imaginary part? See here, a minus b, we consider it a minus b, and we multiply with a plus b. So a 1 minus root 2i, we are multiplying this by 1 plus root 2i in both numerator and denominator. So in denominator it becomes 1 square minus root 2i whole square, s square minus b square. So s square minus b square, 5 into 1, 5 root 2i, root 2i into 1, root 2i, root 2i and root 2i is root 2i whole square, and I square is minus 1, so it is minus 2. So 5 minus 2 is 3, and 5 plus 1, 6 root 2i. So here 3 you can take common. So 3 common, 1 plus 2 root 2i by 3. 3 get cancelled. The answer is 1 plus 2 root 2i. So I hope students have understood the division of two complex numbers. Now what is the modulus and the conjugate of a complex number? So students, the conjugate of a complex number means, let z equal to a plus ib be a complex number. The conjugate of z is defined as z bar, and it just changing sign of the imaginary part. Suppose a complex number is a plus z bar is a complex number a minus ib. So if z is a complex number a plus ib, so z bar is a complex number a minus ib. Only this imaginary part, the sign of this imaginary part will change, not the real part. So if it is a plus ib, z bar could be a minus ib, and if z is a plus a minus ib, then z bar will be a plus ib. And these two, z and z bar, are called the conjugate of complex number. Now what is the modulus of complex number? Z equal to a plus ib be a complex number, then The modulus of z is denoted by mod of z, is defined to be a non-negative real number. Mod of z equal to root over s square plus b square. Okay students, so mod of z is root over s square plus b square, root under root real part, square of real part plus square of imaginary part. For example, what is the modulus of 2 minus 5i? If the real part is 2 plus imaginary part is minus 5, so 2 square plus minus 5 whole square is 29. So this is how we have to find the modulus of a complex number. Now what is the multiplicative inverse? The students, multiplicative inverse formula is z inverse equal to z bar, that is the conjugate of z divided by modulus of z whole square, mod z whole square. So student, there are some working rule of imaginary number. So we have know that I square equal to minus 1. So how we can get I cube? I cube can be written as I square into I. So I square is minus 1. So minus 1 into I, it will be minus I. I to the power 4, I square whole square, I square is minus 1. So minus 1 square is 1. I to the power 5, I square whole square into I square is minus 1 whole square into I equal to I to the power 6, I square cube. So I square is minus 1 cube is minus 1. Similarly, I to the power minus 1 by I. We can rationalize I into I. So I by I square is minus 1. So minus I to the power minus 2, 1 by I square, 1 by minus 1 equal to minus 1, I to the power minus 3, 1 by I cube, 1 by I square into I. So it will be 1 by I square is minus 1. So it will be minus I and again 1 I is there. So it will be plus I to the power minus 4, 1 by I to the power 4, 1 by 1, which is 1. So students, I hope all of you understood the concept of complex number and the algebra of complex numbers. Now I will discuss some application of the complex numbers, some question related to this concept. You can see the first question is, express the given complex numbers given in the form of a plus ib. So we have to express this complex number in the form of a plus ib. So given complex number is 5i into minus of 3i by 5. So first we have to multiply this. So if we remove the bracket, 5 into minus you can keep outside. So 5 into 3 by 5 into 2 i's are there, I into I. So 5 get cancelled, minus 3 into I square is minus 1. So minus 3 into minus 1, it will be minus cancelled, 3 into 1, 3. Next question is 3 into 7 plus I7 plus I into 7 plus I7. So students, first you have to remove the bracket. 21 plus 21i equal to 7i plus 7i square. So it is 21 plus 28i plus 7 into minus 1. So 21 minus 7 is 14 plus 28i. So student, the next question is 1 by 5 plus I into 2 by 5 minus 4 plus I into 5 by 2. So students, first we have to remove the bracket. 1 by 5 plus I into 2 by 5 minus 4 plus into minus 5 I by 2. Now we have to arrange the real part. 1 by 5 minus 4 in one bracket, and taking I common, 2 by 5 minus 5 by 2. Now after simplification we will get the answer, minus 19 by 5 minus 21 by 10i. Next question, similar type, we have to express this in the form of a plus ib. The question in the bracket, in the first bracket, so first we have to remove the bracket. 1 by 3 plus 7i by 3 plus 4 plus I by 3 minus plus 4 by 3 plus minus I. So here we have to write the real part first. 1 by 3 plus 4 by 3 plus I common, 7 by 3 plus 1 by 3 minus 1. So after simplification of this bracket, we'll get 17 by 3 plus I into 5 by 3, because it's 7 plus 8, 8 minus 3 is 5 by 3. So this is the answer of this question, where this question is expressed in the form of a plus ib. A is 17 by 3 here and b is 5 by 3. So it is expressed in a plus ib. The next is similar type questions, where question is given is cube. So first you have to use the formula a minus b whole cube. So students, you can take minus 1 common here. The minus 1 cube will be there, and if you take minus common, then both will be plus. So 2 plus I by 3, 2 plus I by 3 whole cube. So minus 1 cube is minus, so a plus b whole cube, a cube plus b cube plus 3 square b plus 3 thrice ab into a plus b. So 2 cube is 8, I cube is minus I. We can write this step, I cube by 27 plus 3 cancel, twice I into 2 plus I by 3. So minus outside, 8 minus I by 27 plus 4I plus 4, 2I square by 3. Now minus 8 minus I by 27 plus 4I minus 2 by 3, because I square is minus 1, and this become minus. So 8 minus 2 by 3 is 24 minus 2, 22 by 3, and I common 1 by 27 minus 4, which is 107 by 27. The answer is minus 22 by 3 minus plus minus 107 by 27i. So this is a complex number which is expressed in the form of a plus ib, where a is minus 22 by 3 and b is minus 107 by 27. So student, the next question is find the multiplicative inverse of the complex number given. So we know that the formula for multiplicative inverse is this one: z inverse equal to conjugate of z mod z bar divided by mod z whole square. So first you have to find the conjugate of z. Given z is root 5 plus 3i. So conjugate of z, z bar equal to root 5 minus 3i. So students, you know that it means that only the imaginary part sign will change. So here it is plus 3i, so it will be minus 3i. Now what is the mod of z, modulus of z? Modulus of z is root over 5 whole square plus 3 square, and if it is squared, then there is no under root. So mod z square will be root 5 whole square plus 3 square, because we know that mod z equal to root over s square plus b square. Here a is root 5 and b is 3. So if you square it, mod z whole square will be s square plus b square. So root over 5 whole square plus 3 square, it will be 5 plus 9 is 14. Now we use the formula z bar, the multiplicative inverse of z equal to z inverse equal to z bar by mod of z whole square. So root 5 minus 3i divided by 14. So we can write, you can split root 5 by 14 minus 3i by 14. So this is a complex number which is the multiplicative inverse of the given complex number. So students, I hope all of you understanding the concept. Next question is simplify. You have to simplify this complex number. So students, first you have to multiply the brackets 1 in the numerator, 3 into this. So 3 into 3 plus I root 5, 3 minus I root 5. So it will go, you can apply the formula a plus b into a minus b, which is a square minus b square. So a square is 3 square minus I root 5 whole square. This using this formula, a square minus b square, and in denominator we have to remove the bracket root 3 plus root 2i minus root 3 minus minus plus I root 2 or root 2i. So students, here root 3 and root 3 get cancelled, and root 2i here are 2 root 2i, so 2 root 2i. So 9 minus 5i square, so I square is minus 1, 9 minus minus plus, so it will be 14. So 9 plus 5, 14 divided by 2 root 2i. So multiplying I in both numerator and denominator, so that denominator I becomes I square, and we can put the value of I square equal to minus 1. So it will be 2 root 2 I square, and in numerator 14i Now the value of I square is minus 1, so it will be minus of 7 root 2 I by 2. So this is the answer of the given question. So students, the next question is find the modulus and argument of the complex number. So students, so what is the modulus? Modulus is r. How to find r? R is root over s square plus b square. So here a is minus 1 and b is minus root 3. So students, here directly you can find out r square equal to 4, because it is minus 1 square is 1 and root 3 square is 3, so 1 plus 3 is 4, so r square equal to 4, so r equal to root over 4. So the value of modulus is 2. The students' argument is theta. We have to find the value of theta, and theta is sin theta by cos theta. So here let us assuming the minus 1 as r cos theta and minus of root 3 as r sin theta. Here r is the modulus and theta is the argument. So we have got the value of r is 2, and now we have to find the value of theta. So if you divide this by this, r sin theta by r cos theta, then r will get cancelled and it will be minus root 3 by minus 1, it will be root 3. So we have done like this. So students, we have got, since both the values of sin theta and cos theta are negative, here you can see that cos theta equal to minus half and sin theta equal to minus root 3 by 2. Since both the value of cos theta and sin theta are negative, so it lies in third quadrant. So argument will be minus of pi minus pi by 3, which is minus twice pi by 3. Hence the modulus and the argument of the complex numbers minus 1 minus root 3i r, modulus is r equal to 2 and the argument is theta equal to minus twice pi by 3 respectively. So students, I am ending this video lectures. Here I have discussed about the topic complex numbers and its related questions. So if you have any questions, any doubt, you can contact me. Thank you very much.